In this video we have a potter's wheel that is rotating about its center at 20 radians per second. So we have a solid cylinder that is solid, because if it's not solid you can't stick clay on top of it. And it's rotating about its center. So there's a rotation point in the center. Alright, and then we know its mass and we know its radius. And then we stick a piece of square clay with a certain mass and certain length side at the very center. So we're going to stick a square piece of clay on top. And after we stick that piece of clay on there, we want to know what the new angular velocity of the system is, assuming that the process of adding the clay doesn't exert a torque on the system. So that is telling us that we are conserving angular momentum. So our conservation of angular momentum says that the initial moment of inertia times the initial angular velocity equals the final moment of inertia times the final angular velocity. So we first need to calculate our moment of inertias. So our initial moment of inertia is just the rotating solid cylinder. So I looked up this equation in the list linked in Blackboard. So 1/2 mass times the radius squared. So I'm going to take 1/2 times the 25 kilograms times the radius, which is 0.3 meters squared. And that's going to equal 1.125 kilogram meter squared. And then we're going to drop the clay on. So we're going to have still the cylinder and now the clay. So I've looked up our equation once again for it's a rectangle, but you can use the one for a rectangle for a square. I looked up that moment of inertia equation in the table and linked in Blackboard. So we're going to take 1/2 times 25 kilograms times 0.3 meters squared again. So that should be the same as the answer you got for the initial. And we're going to add to that 1/12 times 3 kilograms times the quantity 0.05 squared, so one side, plus 0.05 squared, so the other side. And that's going to give us a slightly larger moment of inertia, so 1.126 kilogram meter squared. So we're going to take our 1.125 kilogram meter squared times 20 radians per second, and that's equal to 1.126 kilogram meter squared times our angular velocity final. So we find out that the velocity only decreases a little, so we go down to 19.98 radians per second.